would you say if you found out that the Earth was flat? How would you feel if you realized that everyone around you spoke an unfamiliar language? What would be the extent of your shock if you were on another planet? Indeed, humans are much more at ease in familiar circumstances, which is why most people don't like change. But it seems that they are exactly what we have in store for us, and global ones at that. We are talking about the discoveries provided by the James Webb Telescope. They overnight undermine the laws on which our entire cosmology has rested for years. Infrared telescope James Webb, not so long ago began to fulfill his duties, has managed to upset the scientific community. He has discovered several galaxies that are too old to exist. Moreover, one of them is older than the Big Bang, which is unthinkable in principle if we rely on conventional hypotheses. What it can threaten mankind, and how it will affect the fundamental laws in which we have hitherto believed. The Big Bang Theory and Hubble's law are what is called the luteal base. They are the basis for most of our understanding of the macrocosm surrounding the Earth. Every schoolchild knows that the Big Bang happened about 14 billion years ago. It was preceded by a singularity point that suddenly detonated and the universe began its expansion, which continues to this day. Then Hubble's law, that is, the universal expansion of galaxies, comes into effect. This is also the basic cosmological law that explains the very expansion of the universe. So what did James Webb do? He took a swing at the Holy of Holies, trying to destroy the foundation on which our astronomy has stood so far. Given that immediately after the explosion of large, bright galaxies with metallic stars could not be formed in any way, the telescope's findings are somewhat puzzling. The fact is that according to modern scientific theories, it is necessary to first appear hydrogen stars, which, exploding at the end of its life, would fill the empty universe with building materials. It was from these that the more mature luminaries and galaxies would later form. Then, how do you explain the fact that James Webb discovered CIRS 2112? This fully mature star cluster formed 2.1 billion years after the Big Bang, which is absolutely impossible if you pay attention to its filling and structure. This spiral jumper galaxy is very similar to the Milky Way, and its mass is nearly 4 billion times that of the Sun. Do you think that's all the discoveries? No, because there is also a galaxy AZ-TAC 71 in the form of a giant blob which the telescope discovered in December 2023. These galaxies have even been recognized as a separate group called the Hubble Dark Galaxies. Scientists at the University of Texas at Austin believe that the detected monster, a real factory of stars, as the process of star formation in the belly of AZ-TAC 71 never stops. Presumably, it is born every year from 1,000 new stars. But the most amazing discovery of the James Webb Telescope occurred in 2022. It's the Jates Galaxy GSZ 13-0. This object is the farthest object ever detected using Earth's optics. The galaxy is thought to have formed just 320 million years after the Big Bang, which is impossible. But to argue otherwise is to disbelieve your own eyes and the readings of ultra-precise instrumentation. According to conventional cosmological theory, active star formation began sometime between 550 and 800 million years after the Big Bang. And yes, they were celestial bodies composed mostly of hydrogen. There was no cluster, galaxy, or metallic stars. And here's an entire galaxy that, judging by its age, was formed before the Dark Ages, a period in which stars were absent by definition. But the fact remains. The telescope's hardware says the galaxy is 13.6 billion light-years old. And if you adjust for the expansion of the universe, that's about 33.6 billion light-years. A monstrous age, absolutely impossible if we rely on the Big Bang theory. This galaxy is located in the constellation Furnace. Some astronomers even suggest that it is a dark star, whose mass corresponds to 1 million suns. What does that suggest? If the James Webb Telescope had detected one such galaxy, it could be written off as a fluke. But 3 objects is a pattern. Plus, we forgot to mention the HD1 galaxy in the constellations Sextant and the Z12I. They currently share first place with JADE's GS Z13-0. It is thought that HD1 may be inhabited by first-generation stars that appeared just after the Big Bang. But that, as the famous meme says, is not certain. The eye of Z12 is likely a dwarf galaxy about 60 times smaller than the diameter of the Milky Way. Consider also this. Given the age of the galaxies mentioned, it turns out that the start of their formation must have begun long before the Big Bang. Isn't that a collapse of conventional theories? Among all the telescopes at our disposal at the moment, James Webb is the most advanced, especially in terms of the optical system. So there's no reason not to trust his data. But you know what's most surprising and frightening? No Earth-based telescope, whether ground-based or orbiting, has so far detected young or infant galaxies with a small number of hydrogen stars in the universe. All the objects, whose photos and data send us optical instruments, are absolutely formed, filled with a huge number of luminaries and very complex in their structure. How to explain this phenomenon in terms of standard cosmology? You may ask, why rely on it at all? Is it impossible to try to come up with a fundamentally new explanation? But the world scientific community is not going to do that. Their goal is to fit their findings to existing theories. On the other hand, you can understand them. After all, you can't break things. But it's not enough to ignore the obvious. You have to come up with an explanation. How do scientists explain the presence of such old, fully formed galaxies where they should not be? Explanation 1. Explosive star formation. The theory is designed to justify the appearance of two bright stars and galaxies in the deepest space. This is where a supercomputer simulation comes in. The result is that in the early days, there was such a thing as explosive star formation. What does that mean? It is believed that at that time the appearance of stars was accompanied by periodic flashes, which caused the brightness of ancient galaxies. They say that it is now star clusters are calm and stable, but before the case was different. By the way, the term explosive star formation astronomers apply to galaxies of low mass, which were those that formed shortly after the birth of our universe. Thus, scientist Zalichatskogo pulled the facts to the nose and concluded that the unexpected brightness of ancient galaxies is not due to their giant size and filling and explosive star formation. Such objects include, for example, the galaxy Messier 82, in which stars are born 10 times faster than in the Milky Way. It is in a thick dust cloud, but James Webb has the advantage of being able to observe objects in the infrared. The second explanation is the aging of light. This hypothesis sounds rather strange, and it practically disproves Hubble's law, which states that the universe is expanding, where galaxies moving away from us are in the red range and galaxies approaching us are in the blue range. Physicist Fritz Zwicky in 1929 attempted to refute Hubble's conclusions. He argued that light simply ages as it travels through the universe, hence the redshift. To put it even more simply, photons of light lose energy by being scattered through space and the gravitational effects of the objects they pass by. Thus, Zwicky argued that there is no expansion and the universe is absolutely static. Until now, the hypothesis had been gathering dust on the shelves, but now it was being presented in a new light. Pardon the claptrap. The fact is that the Indian scientist Gupta, working in one of the Canadian universities, decided to combine the theory of aging of light with the theory of the expansion of the universe, so to speak, reconciling their postulates. What follows from this? Astronomer came to the conclusion that, in fact, given the above theories, the Big Bang happened much earlier, over 26 billion years ago. So the light we observe during this time has aged quite a bit. Explanation 3. The theory of nature's variable constants. It's quite simple to understand. It says that the laws of the early universe and the laws of the present are two big differences. That is, the constants that we now rely on as monumental may have changed over time. Here it is also worth mentioning the modified Newtonian dynamics or Monda theory. In it, Israeli physicist Mordechai Milgram attempted to explain the rotation of galaxies without including dark matter in the formula. All this in a complex, as some astronomers believe, is intended to explain some inconsistencies of our laws with the received data. Did the above explanations and theories convince you? Did they make you doubt the Big Bang Theory, Hubble's law, and other cosmological postulates that have been reigning in the scientific world for many years? We are, frankly, at a loss. The only conclusion that can be drawn from this situation is that everything we were sure of is collapsing right now. Seemingly solid towers are collapsing, foundations are sagging, ceilings are breaking. James Webb has chosen the language of facts, which are very hard to argue with, and fit them into convenient schemes. So for now, we advise you to take the position of an observer, stock up on popcorn, and continue watching this cosmic spectacle. If you look around our universe, you can see that it is permeated with many shining galactic threads and walls. Between them stretch vast stretches of the deepest void, hundreds of millions of light-years in diameter, which are called voids. These grandiose cosmic gaps reach such an incredible size that the largest galaxies seem like grains of sand against them. And some stars burn to ashes faster than a photon travels from one edge of the cosmic abyss to the other. Even the omnipresent echo of the Big Bang is silenced in their vast depths, which hold many secrets and mysteries, which means it's time to venture into the heart of the great cosmic void. Cosmo. In terms of the vastness of the cosmos, our planet is just a small, rocky wreck at tremendous speed, hurtling through the vast void. For billions of years it has been circling its orbit, maintaining a distance of about 150 million kilometers from the Sun. But the true size of our system is much larger. According to modern ideas, its outer boundary, which is considered the far edge of the hypothetical Oort cloud, runs at a distance of about 100,000 astronomical units. Beyond this boundary begins the boundless abyss of the interstellar vacuum, a space so rarefied that there is on average only one single hydrogen atom per cubic centimeter. The distance between the nearest stars in our part of the galaxy is on the order of a few light-years. And a photon leaving the Sun can reach Proxima Centauri without ever colliding with a particle of matter. This vast void is pervasive and integral to the deep structure of the cosmos. It permeates the entire Milky Way with an unbridgeable chasm, separating stars and planets, black holes and white dwarfs, super-dense pulsars and diffuse nebulae. If you travel beyond the galaxy, you can see that it is surrounded by an even deeper vacuum. For example, between us and the Andromeda Galaxy lies 2.5 million light-years of super-thin space. It's a distance so vast that 25 galaxies like our own could fit in it. But it's filled only by the deepest cosmic vacuum, and that's only a small part of the great cosmic abyss. All-pervading invisible threads of gravity tie together the Milky Way, the Andromeda Nebula, and the Triangle Galaxy, as well as about 100 of their satellites. This structure is called the Local Group, and is a large cluster of cosmic matter about 10 million light-years in diameter. In turn, the Local Group is part of an even larger formation, a relatively small galactic filament by the standards of the universe, called the Local Sheet. This flattened structure, made up of several hundred galaxies, is about 46 million light-years in diameter and about 5 million light-years thick. The sheet is part of an even larger association called the Virgo Superscale. However, very close to the local leaf, outer space suddenly changes its appearance. Here, the usual colorfulness of the universe is broken by a giant black hole known as the local void, or local white. In fact, the local sheet is one of its walls. Other conventional boundaries, however, are the Perseus fish supergroup and the Peacock Indian supercluster. At the same time, void is divided into conventional parts by several sparse galactic filaments, and wide passages link it into a single network with the Sculptor and Hercules voids lying nearby. Due to the cosmological expansion of the universe and the gravitational influence of the surrounding matter, the volume of the local void is slowly increasing. Currently, its diameter is about 150 million light-years, and the distance to the center is at least 70 million light-years. Meanwhile, the nearest edge of this cosmic void is located very close to Earth, at a distance of about 3.2 million light-years. Due to this proximity, the local void occupies a significant part of the night sky of our planet, about 40%. The main plane of the Milky Way, containing many bright stars and large nebulae, closes the central part of this region from us. However, its edges remain observable. In 1854, a dwarf spiral galaxy, named NGC 6503, was discovered a little north of the constellation Hercules. Later, with the development of observational techniques, it became known that it is located in the middle of a local howdah, and its distinguishing feature is the incredible multicolor appearance. The spiral arms of the galaxy are permeated with bright red clots of heated hydrogen, and shining blue nebulae are the birthplaces of stars. The center is obscured by clouds of cool gas and dust, which have a noble brown color. The diameter of NGC 6503 is about 30,000 light-years, and the distance from Earth reaches 17 million light-years. Thanks to the attraction of the Virgo supergroup, this galaxy is approaching us at a speed of about 43 kilometers per second. It is believed that its gradual approach to the local sheet will eventually saturate its space with interstellar hydrogen, triggering an increase in star formation. According to calculations, in a few billion years, the number of young stars could double from the current number, and the small galaxy will shine with renewed vigor. The motion of NGC 6503 is a clear demonstration of how the howdahs are likely to have formed. The foundations of the large-scale structure of the universe are thought to have been laid in the first few minutes of its existence, at a time of chaotic mixing of matter and energy. Cosmic cataclysms of incredible power shook the young universe, creating localized compaction and voids. Subsequently, clots of matter became proto-galactic clouds, and low-density space became voids. Over time, the pervasive influence of gravity intensified this contrast, pulling stars and cosmic gas into relatively dense clusters, making the space of voids even more rarefied. Observations show that the vast majority of galaxies formed between 10 and 13 billion years ago. In addition, no significant differences between the age of galaxies located in voids and those that form global filaments have been observed. This fact also confirms the current theory of the formation of the large-scale structure of the universe. Meanwhile, knowing about the cosmological expansion of space, we can assume that with time the local void will become larger and more rarefied, and the Virgo supergroup will gradually disintegrate into several independent groups. At present, it is an association of about 30,000 galaxies, concentrated in a region of space with a diameter of about 200 million light-years. At the same time, the total mass of the cluster is about 1.5 quadrillion solar, which is similar to about 1,000 galaxies such as the Milky Way. The Virgo supercluster is partially contiguous with two other galactic superclusters, Centauri and Peacock Indian. At the same time, another side of it borders a vast region virtually devoid of matter. It is called the Taurus void and is one of the largest known cosmic voids. Exploring this area of space is very difficult. It's because most of the void lies in the so-called avoidance region, a sector closed off from us by the plane of the Milky Way. The bright stars in our galaxy obscure the fainter and more distant sources, and interstellar matter absorbs and scatters their light. However, thanks to infrared studies, we do have some insight into the structure of this howdah. The diameter of this grand void is on the order of 200 million light-years, and the distance to the center is about 150 million light-years. When observing the void, a remarkably clear boundary between the relatively empty space and a bright cluster of galaxies located noticeably farther away immediately catches our eye. It is called the Perseus-Pisces supergroup and is one of the largest in this part of the universe. Such a sharp transition is characteristic of dust clouds, but infrared studies do not confirm their presence. In all likelihood, a clear boundary between the Howl and Superscope due to gravitational causes, but the exact mechanism of their action we have yet to find out. Meanwhile, it is assumed that the Taurus Howl, like most other cosmic voids, is not as empty as one might imagine. Distortions of light passing through it suggest that this area may hide in its depths giant gas dust clouds, the cradles of future galaxies. According to other hypotheses, inside the void may hide huge masses of dark matter, the most mysterious substance in the universe, the properties of which are still not fully understood. The most daring ideas place in the centers of cosmic voids, clots, antimatter, or even more exotic matter possessing negative mass. However, despite their boldness, these hypotheses lie already outside the boundaries of generally accepted scientific concepts, making them quite difficult to experimentally verify. Currently, only 2 separate galaxies have been discovered, lost in the space of the giant howdah. One of them, UGC 2627, has a spiral structure and resembles the Milky Way. The second one is known as UGC 2629 and belongs to elliptical dwarf galaxies. Both objects are located almost in the heart of void, at a distance of about 185 million light-years from us. But the distance between them is small, and lies within a few 100,000 light-years. Perhaps there are other single galaxies lurking in the empty space, but the disk of the Milky Way does not allow us to see them. Meanwhile, the Virgo supercluster, along with 4 other superclusters, forms a giant galactic filament called Laniakea. It contains more than 100,000 galaxies and stretches more than 500 million light-years across space. Its gravitational center is the Great Attractor, a mysterious supercluster of galaxies located 250 million light-years from Earth. In turn, Laniakea is part of a vast galactic stream, and further away you can see that most of it is surrounded by a black abyss of unprecedented proportions. The light of distant galaxies drowns in its emptiness, and even the mysterious and elusive neutrinos take billions of years to cross this cosmic abyss. And it's hard to believe that despite all the advances in observational technology, such a gigantic void was spotted just 10 years ago. 2013, University of Wisconsin-Madison. A team of astronomers led by Professor Amy Berger is engaged in determining the remoteness of galaxies. In the process, they discover an unexpected and stunning fact. It turned out that Laniakea, as well as most of the surrounding superclusters, are surrounded by a cosmic void of unprecedented scale. Scientists have calculated that its diameter exceeds the size of any known voids. The scale of the discovered void was so enormous that it called into question several fundamental cosmological principles. Clearly, the universe was far more complex than we had imagined. The research of Amy Berger, Ryan Keenan, and Lennox Cowie has led to what appears to be one of the greatest astronomical discoveries of recent years. Their work has shown that our galaxy, along with its surroundings, is located in the middle of the largest supervoids known to science. It's called KBC, after the first letters of the discoverers' names. Observations show that the shape of the giant void is close to spherical, and the diameter may exceed 2 billion light-years. According to calculations, the Milky Way is located several 100 million light-years from the conventional center of the Great Space Abyss and about the same distance from its edge. The discovery of a giant bubble of emptiness surrounding Laniakea allowed to explain the paradox that did not give rest to scientists for many years. The fact is that all galaxies in the universe are gradually flying apart due to cosmological expansion. Measuring the rate of this motion allows us to calculate the so-called Hubble constant, a fundamental physical constant characterizing the rate of expansion of space. However, if we take for the calculation of the Hubble constant the galaxies closest to us, it turns out that the rest of the universe is expanding too slowly. Conversely, if we take distant objects as a basis, the Milky Way's surroundings are moving faster than they should. Void's discovery put everything in its proper place. The point is that the galaxies inside it, including the Milky Way and its neighbors, constantly experience an additional gravitational force from objects outside the void. This creates an added force that gradually stretches our cluster in different directions. It is also surprising that the KBC void is so huge that it includes not only the supercluster of galaxies, but also other voids. For example, the local void, as well as the Taurus void, are part of its structure. It turns out that compared to other howdahs, the KBC looks large, but not so empty. Nevertheless, against the background of the observed part of the universe, the diameter of which, according to calculations, reaches 92 billion light-years, even the UN, just a barely noticeable dark spot. If we look at the global map of the universe, we will see on it a lot of dark spots on their scale close to the KBC Howdah. Most of them easily fit within the framework of modern physical theories. Others, however, show surprising and strange properties, difficult to explain from the point of view of science. And one of the most notable of these cosmic mysteries is the Ridan supervolume, also known as a relic cold spot. According to calculations, its diameter is between 500 million and 1 billion light-years, and its distance from the Milky Way is between 6 and 10 billion light-years. This means that this formation is one of the most extensive elements of the large-scale structure of the universe. Void is located in the southern hemisphere of the Earth's sky and occupies an impressive area on it, several times larger than the full moon. However, it is impossible to see it with the naked eye. Relict spot is visible only with the help of special telescopes that study space in the microwave spectrum. Thanks to them, astronomers have found that within the spot relic, radiation of the universe is about 70 microkelvin colder than the average metagalaxy. This deviation is almost 4 times the strongest anomaly previously recorded, and its gigantic size makes it a truly mysterious object that requires extensive study. It is currently believed that relic radiation, traveling through hundreds of millions of light-years of deep vacuum, experiences gravitational effects from distant galactic superscopes. This causes all the penetrating echoes of the Big Bang to lose energy, making the relic spot appear cooler in images than its surroundings. Nevertheless, this effect is not able to fully explain the excessive cooling of the relic radiation. According to calculations, the attraction of external galaxies can explain only a quarter of the observed deviation. It is assumed that the remaining 75% of the effect may be due to the impact of hypothetical dark matter or dark energy concentrated in the depths of the void. However, it will be a very long time before we can truly unravel this cosmic mystery. As we observe the cosmos, we see hundreds of millions of galaxies scattered in space, each of which includes billions of all kinds of luminaries, trillions of planets, and countless other celestial bodies. This infinite diversity creates gigantic cosmic structures, covering space with a shining network. But all this is but glittering dust against the great void that fills the universe. This void is the true cosmos, mysterious and dangerous. Maybe in its depths lie the answers to the key riddles of the universe. Or maybe there is nothing there but endless darkness, hardly comprehended by the mind. Only time will tell if we will one day learn its secrets.